Hey everybody, this is Miss Kaiser with just some final thoughts to make sure you are ready for your quiz on exponential functions. So I am using one of the documents that we have on Google Classroom where I gave you some I can statements, and then over here we had some notes. Just to go through this one more time, one thing you'll be tested on is how to interpret an exponential equation. So you may be given a word problem and you have to figure out what would be the starting value, which would be the y-intercept. You may have to figure out what would be the common ratio, that b value there, okay? And like the example we saw in class, you might be given a word problem and you would have to know if it was linear or exponential, and then again be able to pick out the accurate y-intercept and the accurate slope if it's linear, or common ratio if it's exponential. So those are pretty basic, pretty easy. Just remember your forms: linear, y equals mx plus b, and exponential, y equals a times b to the x. If you go back to those, you'll be fine. Okay, write exponential equations. In this situation, I would give you a graph or a data table or a word problem. You would have to figure out what is the y-intercept, that's where you put in for A, or you, well, and, not or, you would need both, and you would pick out the common ratio, and that is your B, right there, okay? When you have y-intercept and you have common ratio, then you can put those into the formula for an exponential equation, and you are done with that. One note about this: if I give you a graph, it might be easy to see the y-intercept, but it might be hard to picture what the common ratio is. So when you are given a graph, remember, you can make a data table. Make a data table, have your x and y values, and fill in x and y values. And then from the data table, then it's easy to see what is the common ratio, meaning what am I multiplying by every time to get the next number. Is it multiplying by 2? Is it multiplying by 3? Is it multiplying by 1/2 or 1/4? That is your common ratio. And again, it's easier for me to see that if I have it in a data table. Calculate line of regression. At this point, you would have a calculator. You would get a calculator, and you would be given a complex data set. And remember, you're going to go to stat. So if you forget this, I know it's very new, so I can help you remember how to enter things in the calculator if you forget on the test. So don't stress out about that. I can help you if you forget something there. So remember, you go to stat, you enter your ordered pairs and your L1 and L2. Make sure that you have the accurate ordered pairs. Make sure your X's and Y's line up. And remember, you go back to stat, go over to calc, and we're looking to do an exponential regression because we're getting the line of regression. And remember, it will give me A, which is my y-intercept, and it'll give me B, which is common ratio. And if you have those two, you can write the equation. Sometimes you need the equation to do this next piece. Use that line of regression to make a prediction. So usually you will be given X and you will need to find the Y, the output. But just be very careful, read carefully to make sure you are putting in the right number in the right place. And then you want to make sure your answer would make sense in the real world. Like in one of our practice one, it asks you how many coins. On the calculator, you get 16.54 or whatever, but obviously you can't have 0.54 of a coin in this situation, so you would round up to 17 if that were the case, or 16 depending on what the situation is. Here, I want to determine if a function is linear or exponential, and we already talked about this as far as seeing, does it have a constant slope which would give me a common difference that I can see in the data table, or does it have a common ratio? So again, to me, if I'm looking at the graphs, it's pretty easily, obviously, to know, is it a straight line or do I see exponential growth or decay? If I don't have a graph, but I have a data table, I can graph it and look at it and make sure. But I can also use my data table just to see, does it have a common difference or does it have a common ratio? What if it didn't have a common difference or a common ratio? Then I would know that's not linear and that's not exponential. Finally, solving a system of equations or inequalities where one function is linear and the other is exponential. So we talked about how there's lots of things going on here. When they give me a word problem, I have to know that it's a system if they're looking for me to find when two things are the same or when something is going to be greater than or less than something else. So they give me two different situations where I know I'm going to have to write two equations, and then they ask me where are they the same, that system of equations. If they ask me where one is greater than, less than, then I know that's system of inequalities. Then I have to actually be able to write the equations. So I have to know if it's linear or if it is exponential. And then if it's linear, I need y equals mx plus b. If it's exponential, I need y equals a times b to the x. Then I actually solve. And then if I solve for x or I solve the inequality, I have to find out again, are they asking me for that x? Or are they asking me for some other answer where I use the x to get that answer? That was the situation we had with the practice problem we did with the two towns with the population census. Once I got that x had to be equal to 3 to get that greater than situation, that wasn't the end. I had to then figure out how to use the number 3 to get to my final answer. And sometimes that's the case on these multi-step word problems. So I hope that helps you with exponents. The only other thing that I would remind you of is to remember some of those basic rules. Anything to the power of 0 is going to be 1. And anytime you take a number to the -1 or to the -2, remember you have to say 1 over and then put that value on the bottom. So for example, if I have 2 to the -2, I have to say 1, that equals 1 over 2 squared. So 2 to the -2 power equals 1 over 2 squared, which is 1/4. But sometimes people are forgetting those rules, and then that messes them up when they're trying to do a data table. So I wanted to remind you of that. Good luck.